What is the hot reservoir's role in COP? Have you ever wondered how heat pumps and refrigerators work so efficiently? One key player in this process is the hot reservoir. Let's break down its role in the coefficient of performance, or COP, and see how it affects thermodynamic systems and cycles. In simple terms, the hot reservoir is where heat is either delivered or expelled, depending on whether we are heating or cooling. For heat pumps, this is the area that receives heat. The COP for heating is calculated by taking the amount of heat delivered to the hot reservoir and dividing it by the work input needed to transfer that heat. So, if we think of it mathematically, COP equals heat delivered to the hot reservoir divided by work input. Now, here's where it gets interesting. The temperature of the hot reservoir plays a big role in how much useful heat the system can provide. If the hot reservoir is at a higher temperature compared to the cold reservoir, more work is required, which can lower the COP. On the flip side, if the temperature difference between the hot and cold reservoirs is smaller, the COP increases, meaning the system operates more efficiently. For refrigerators and air conditioners, the hot reservoir is where unwanted heat is expelled. The COP for cooling is determined by the amount of heat removed from the cold reservoir divided by the work input. The temperature of the hot reservoir still matters here because the system needs to reject heat to it. If the hot reservoir temperature is high, it becomes more challenging to reject heat, which reduces the COP. The theoretical maximum COP for both heating and cooling is based on the temperatures of the hot and cold reservoirs, expressed in absolute temperature units like Kelvin. For heating, the maximum COP is the temperature of the hot reservoir divided by the difference between the temperatures of the hot and cold reservoirs. For cooling, it is the temperature of the cold reservoir divided by that same difference. These formulas show how important the hot reservoir's temperature is in determining the upper limits of performance for these systems. In practical terms, managing the temperature of the hot reservoir is essential for designing effective heat pumps and refrigerators. Systems that can operate with a smaller temperature difference between the hot and cold reservoirs achieve higher COPs. This means they use less energy to transfer the same amount of heat. This principle explains why heat pumps work better in moderate climates, where the temperature difference is less compared to extremely cold environments. So, the hot reservoir's role in COP is vital. It serves as the destination for heat transfer in heating systems and the point where heat is rejected in cooling systems. Its temperature relative to the cold reservoir sets the efficiency limits and performance of heat engines, refrigerators, and heat pumps. Understanding this relationship is key to designing and optimizing thermodynamic cycles for energy-efficient heating and cooling.